Welcome to our bookie call for the weekend of August 23rd, 24th. I noticed my video doesn't seem to be working on my side. Can you guys see my video? Uh,
No,
No,
no. Okay, I'm going to
no.
try and put it off and on and see if I can get it to go. I think it's got I have a memory issue on my computer. There, I'm back now. Let's see
now
if,
you're back.
okay, good. So welcome to the phone call. Manu may be joining us. I'm not sure that Joe will be. Um, And but here we are, and we're about ready to study. We're picking up on polar explanation, and we're starting on towards the bottom of the last two paragraphs on page 181. And so, Anne, how are you feeling, and what do you anticipate getting out of today's calls?
Um, okay. I find that the Wednesday, our this Sunday morning for me, Saturday night meetings, is a lot of grounding. Yeah. So I love the Sunday ones because it really grounds everything that we talk about. Wednesday is like what it was when I first started, which is you're listening and you're just absorbing, right? And it's more like I would say that it's laying the groundwork for what's coming to me, yeah, what's coming for me. And so then and the funny thing is, even though we are talking two different books and all that, but every time it kind of comes together, whether we're talking on Sunday or Wednesday. Okay. And it's not because Bucky covers so much, right? Yeah. But it's I think the word you use is serendipitous. Yeah. That it comes at that point when it just makes sense, and it just comes at that point. And then when the two comes together, the whatever I'm hearing, whatever I'm seeing, it's just crazy out there, right? So anyway, happy to be here. And let's see what else I'm going to ground on this Sunday morning. Okay. So Richard, how do you feel, and what would you like to take away this Saturday evening?
Uh, let's see, how am I feeling? I was going to maybe start off and say I'm feeling very jittery, um, yeah, meaning jitterbuggy.
Yeah.
Um, no, one of the things that kind of struck me last week when we were going through that particular chapter, and I underlined quite a few things, but one was the word dynamic geometry. And
Mm.
and that really struck me because so often when we're referring to synergetics, the book, we're looking at the subtitle, which has to do with the geometry of thinking. And it struck me that the dynamic geometry is is a bit more meaningful in the sense that the modeling, like say a tetrahedron, is not stable, is not static. There is movement, there it's dynamic, and especially the notion of the interweaving between, or the relationships between the vertices. Um, and I know in another conversation, I often talk about dynamic equilibrium, which for me is very close to what I've learned several years ago about the importance of far from equilibrium as the ideal sort of health state, where you're in a robust sort of context that allows you to stretch and learn as much as possible or contribute as far as you can. And then you need to sort of fold back into some rest and take time off and look after self and that kind of thing. So it's very dynamic, the whole idea of equilibrium. It's not a static notion. And so I'm wanting to explore that some more in our readings to see whether or not dynamic geometry is another way of being able to talk about synergetics. Um, that takes me a bit beyond the idea of just geometry of thinking. Um, it gets closer, I think, to the applied side of this, and what can I do with this learning if I was, well, at my age now, I'm still thinking about applied ways, but again, I think of Anne and your young students and constantly trying to facilitate ways in which they can take what they're learning and eventually apply it in a practical, contributing way in society. Um, and dynamic geometry helps me think of what those students um, can do now, as you've shown in some of the TED Talk um, experiences that you've seen their performances and what they can do once they become young adults and into that part of their life. So I'm really looking forward to continuing to dig into fuller explanation. Um, Steve, how are you feeling? What's your expectations for this evening?
Well, I'm feeling pretty good. I'm a little bit, if I think about it, if I pause, when I slow down a little bit, I feel a little bit tired, but I haven't felt tired until I was slowing down to get ready for this call. So, but I love these calls and I love what's going on. During the week, I heard about there, and I was just looking for a printout I put together on it because I was holding some of the ideas, but it was talking about um, music, and it was talking about multiphonics, and started to talk about dynamic equilibrium and stable equilibrium, uh, and how a sine wave gets created in a stable equilibrium. It was kind of interesting, and I thought of Manu, of course. Um, but this whole I'm just learning. There are different ways to look at life, and a lot of different disciplines have different definitions for words, even like the word equilibrium. So um, it's really interesting to me, and uh, I'm looking forward to further enlightenment. Um, I have a little pre-summary statement as to where we're going to go tonight and tonight's call, but Manu has joined us. And so, Manu, why don't you tell us how you're feeling and what you anticipate for today, and then throw it back to me, and then we'll begin the call. Good to see you.
Good morning. Feeling good, emergent, and happy to join the call. Okay, so I'm listening. So let the train take us to where he has to take us.
Okay,
Steve.
very good. Good to have you. Glad you're on as we start, so you get every morsel of what we're looking at. I also want to mention that Lee was looking forward to tonight's call as well, and then she started feeling a little under the weather. She may join us a little bit later on, but Joe and Lee aren't with us tonight, so we'll until they get here, and they just both might get here. So let's see here. And we are recording, so life is good. I'm going to begin the screen share. And as I do, um, uh, Richard was very wise to point out that he feels jitterbuggy because, in fact, we are in chapter 11, which is the jitterbug. And as we have been as we go down through this here, page down, we started. The book is describing what occurs in the jitterbug as it goes down, and then folding the polyhedron. And here we are right here towards the end, and we're about to get into the final phase of the jitterbug. So we're starting right here. I'll go ahead and start reading, and I love to switch it around. And so, if you feel like reading, I'm only going to read a couple, 3 paragraphs. We'll go from there. This contraction is continuous. All right, so I'm going to start up a little higher. Instead, keep going. Past the icosahedral stage, the diamonds, ever thinner, soon become narrow slits and finally snap shut, as shown in figure 11C and D, which was which goes into the octahedron. Finally goes into the octahedron and snaps shut. The dance comes to a halt in the form of an octahedron. There we go. 24 sticks have come together into 12 pairs, creating a double-edged octahedron. This contraction is continuous, and so there are countless slightly different stages, but only 3 are significant geometric shapes. That's kind of interesting to me. I hadn't thought of that. There are countless slightly different stages, but only 3 significant geometric shapes. The jitterbug is of interest primarily because of its surprising flow from one polyhedron into another. The emphasis is on its motion. Moreover, we do want to be familiar with its geometric checkpoints. First, the vector equilibrium. The unit vector edges are balanced by unit length radii. When the system contracts to the icosahedra position, the distances between each vertex and its 5 neighboring vertices are suddenly the same. Unlike the vector equilibrium, in which each vertex has only 4 nearest neighbors, each one the unit distance away, while 2 additional neighbors are approximately 1.414 units away, i.e., the length of the square's diagonal. I'm picturing that. I hope you're able to do that too. So to accommodate this surface equivalence, the radius must decrease from 1.0 to 0.9511. Nature will not compromise on these numbers. For all neighboring vertices to be separated by equal lengths, the radius must be shorter than the length. A perfect static balance is impossible, hence the dynamic, eternally fluctuating events of universe. I'm sure there's something there I have not understood before. The 12 vertices continue their inward journey until they land at the 6 corners of the octahedron. Sets of dowels clamp together, grouping the 12 vertices into 6 pairs. Look at 11D. That's over on page 180 if your book happens to be open, and that is the cube octahedron, or that is the octahedron, the double-edged octahedron. The radius has decreased to 0.7071 times its original length, and that's the end. But wait, there's another twist left in the jitterbug. Hold on to that top angle, which has been so carefully kept from rotating until now, and deliberately start to twist it. The triangle will only yield in one direction, depending on the direction of the jitterbug's initial twist. If you turn it far enough, 180 degrees, the entire system collapses into a flat 2-frequency triangle spread out on the table. Then fold the 3-corner triangles like petals of a flower, bringing their edges together to create the 4th and final stage, the minimum system of universe, the tetrahedron. So it goes from an octahedron to a tetrahedron.
Yeah, that's
We can
interesting
pause
too.
right there. Go ahead.
Well, I'm just saying it recreated the image for me a little bit more clearly in the sense that it goes from the octahedron down to the 2-dimensional tetrahedron, and then you fold up the triangles to get if you want, the 3-dimensional tetrahedron. And then for me, I can fold it back down to the 2-dimensional laid out tetrahedron. And then I believe you can fold it in such a way that you end up with a several edge length triangle. So you can take it all the way down to the triangle.
Okay.
Mm-hmm.
Yeah. I thought that was pretty descriptive wording too. Okay. It's a dense tetrahedron with 4 parallel sticks for each of its 6 edges, 3 converged vertices at each of its 4 corners, and a radius of 6124. Now, I might understand that that radius is from the center of gravity of that. It's from the center of the tetrahedron out, right? To each of the vertices. That's what it's talking about. The radius.
Mm-hmm.
Okay, good. Then if I got it, then I got it. Quadrivalent, says Bucky, and hence full of explosive potential, ready to spring back into our friend the vector equilibrium. This folded model also demonstrates the tetrahedron turning itself inside out, for the three petals can be opened and flattened out again, and then folded back in the opposite direction, creating the mirror image or negative tetrahedron. Fuller then reminds us that the unity is plural at a minimum of two, and every system has an invisible negative counterpart. And he says negative universe is the complementary but invisible universe. Such digressions are unavoidable. For Fuller, the implications of a model are always multifaceted, one observation plunging into another, layers upon layers, intertwined. You know, would it be helpful for you guys to see the jitterbug video from Bucky again? I noticed that after the call the other night, I went ahead and checked it out, and it's only 3 or 4 minutes long. And I just, if it's okay with you guys, we'll watch it again. Are there any comments? Maybe we don't need to watch it. I'm not trying to hijack the call. What do you guys think?
No, it'd be fun. It's always fun to see that demonstration of pushing down on the top triangle towards the bottom triangle and the twisting motion that brings it all the way down to the flat tetrahedron.
Cool. I should have loaded it up in the first place. Well, let's just see if I can get this thing to roll. Here we go.
And it is equilibrium is a very completely unstable condition. That is when we first had submarines, we used to fill the water ballast tanks so it was just at equilibrium. And then if anybody happened to just drop a monkey wrench over, we could so balance out and they would tend to nose over and get into great deal of trouble. When we began flying, then we came to what we call the star. Star because they fly when and the equilibrium at the star, anything could happen, can go any kind of a spin.
There's nothing shown, Steve. There's nothing on the screen.
Nature abhors at it.
What's that?
There's nothing on the screen.
Let's see what we got here. All right, you're right. I know what I did wrong. Hang on just a second. Thank you, Manu, for pointing that out. Funny. And I know why it's showing on over here on this thing, but it didn't show. It wasn't showing on the screen, and so I've caught it now. And here we go.
Vector equilibrium where the radii have been removed, that is explosives. And equilibrium is a completely unstable condition. That is when we first had submarines, we used to fill the water ballast tanks so it was just at equilibrium. And then if anybody happened to just drop a monkey wrench over, we could throw the ballast out and they would tend to nose over and get into a great deal of trouble. When we began flying, then we came to what we call the stall. Stall is simply a point when at equilibrium at the stall, anything can happen, can go any kind of a spin. Nature abhors that equilibrium. She always, everything you and I know will always be one side or the other of the equilibrium. At any rate, this is the most expansive form of these vectors that I gave you. Now here's vector equilibrium. Can everybody see this all right? And I'm going to take this top face and move it, lower it towards the face on the floor. And this top triangle is not allowed to twist. It can only approach the triangle on the floor. You've got two planes approaching each other. Understand? So this means this vertex will always be towards you here. And the vertex on the floor is towards me. So I'm going to do this. Suddenly, it's collapsed to where the square are changing. They become diamonds, then ridgepole diamonds. Now the distance between the vertexes is such that the line is exactly the same as the other vectors. Therefore, I put in 6 vectors there, and you have the icosahedron. This is the icosahedron. Vector equilibrium then comes down to the first stable form, which is the icosahedron. The vector equilibrium itself consisted of 8 tetrahedra, each of a volume of 1, 6 1/2 octahedra. A half octahedra is 2, so 6 times 2 is 12. 12 and 8 are 20. The vector equilibrium volume is 20. And so it now collapses, correct. I want to say that 20ness of the vector equilibrium gets tightened up into the icosahedron with another set of vectors. 6 more introduced, or 1 more unit of quantum. Now I'm going to keep lowering that triangle, total on the floor, not twisting at all. And now it suddenly contracts to become the octahedron. This is a very beautiful thing you watch. All vertexes approach common center at a common rate. There's absolutely symmetrical expansion. Comes by up here and now contracts the other way. But the axis in my hands never rotates. Only the equator is rotating. Now I can go, supposing this is rotating in space, this group of stars, there's a mass attraction pull of another set of stars, and one then, this is trying to turn, and then it restrains this. What happens when you do that would be then, I move this around, it forces it to contract. If it's being forced to contract that way, then, remember, notice it's rotating this way. This rotates more and plunges right through and becomes the tetrahedron. We've gone all the way from vector equilibrium, icosahedron, octahedron, vector equilibrium. The octahedron is double bonded, tetrahedron is quadruple bonded. Quadrivalent, we call it. This way diamonds are with respect to carbon. We have no point to break open. So the maximum space employed by unity is a vector equilibrium, but all the structures are within it. They're contracted form from the whole. Now notice that this can then tetrahedron, I've had it plunge that through like that, but this can then immediately reverse itself and tetrahedron can turn inside out. The other way. Just does it absolutely spontaneously. There's basic pumping. Okay. that identifies vector equilibrium and introduces a hierarchy of accounting.
Cool. So, any comments or on that, or should we just continue reading? Go ahead, Manu. You need to unmute, though, before you start.
Okay. Did you understand the most important point of that demonstration?
Well, what is that?
Is the poles.
A pulse.
The poles. Poles.
Oh, the poles.
The
Okay.
top and the bottom triangle don't move.
Yeah.
He repeated that many times. You hold them fixed. If you replay, listen to it. The top triangle and the bottom triangle don't move.
That's right.
It is like this pen. I hold it like this. I hold the top and the bottom. It doesn't move. Now, if I press on this pen and the energy that is in is constant, what it's going to do is going to expand in the middle here on the equator. And it's going to expand by a spin. That's the only way it expands. Because if it is held like this, it's just compression. The dual of compression has to come to play. When I'm holding like this and I'm pressing, what it does, it twists around here. It twists, it turns, it spins and expands on the equator. That is one very, very important point. The second point was the word continuous. And it stems from the first principle of energy, that energy always flows. And note that is first, the vector equilibrium is a mimic, a local IVM. Is a cube octahedron that is started with. It started with 12 triangles, vertices be linked point to point, alternating with squares or rhombuses. That is the cube octahedron. Those are the 3 points that I wanted to put up here. Okay, I'm through.
Cool. Any other insights, notations, comments?
Yeah, I kind of may need a bit of thought from all three of you, yeah. Because you know, like we're talking about the jitterbug, and then in comes this unity is plural at minimum 2. And I really like this thing about every system has an invisible negative, but okay, I'm going to pause at the unity is plural at minimum 2. Now, over the years on the call, there have been quite a number of the things that we talked about. And when you get to a point where you get it, you know, and it goes bam, right there you go, wow, you know. So like things like pre-session, I found the bank that wow, you know, moment. And then a whole bunch like ephemeralization, this dynamic equilibrium, and yes, going into dynamic geometry and geometry of thinking. This is the one I'm really excited about. But the one that for me, unity is plural and at minimum 2. I've heard that for years. It started with attending Blair Singer's training. Yeah, and then because we went to quite a few of his, and that would show up. And of course, none of us in the audience as his trainees ever got it at that point, right? And then along comes Kelly. Then he started in his training. He always, every now and then, he goes back to this unity is plural at minimum 2, and then he pops up in our school. He comes over to visit our school, and he sits down and spends time with my team, and he talks. And again, this unity is plural and at minimum 2, right? So again, suddenly we're talking jitterbug, and this shows up again. Okay, maybe what I'm asking is this: I have not gotten to that. Wow, this is what you know, unity is plural at minimum 2 is, right? I see the duality. I see, you know, yeah, we can pull that out and so on. But what do you, each of you, when you, because for all three of you, this unity is plural. It also it just pops out. So that means the significance of it is huge, right? like we talk about the cosmic hierarchy, for me, is also huge for me. Cosmic integrity, synergy, all that is huge. But I just haven't like gotten down to this unity is plural at minimum 2. Is that an okay question to ask here? I mean, at this point, does it?
By the way, Anne,
Mm.
I remember that I was with you in KL in 2010 at that
Oh,
Blair Singer training. I was with you. I was there. Look at pictures. I was there.
that's
In 2010, in KL.
right. It was my first
And I
blessing.
remember you were with a lady. I remember Kelly talking to you on the side
Yes,
when we were
yes,
having breakfast. I remember now.
right.
You were there. I was there. And then we did the experiment of putting the arrow on the.
Yes, that's right.
Yes. I was there.
Oh my God, that's and
If you take the
you know,
picture, if carefully look at the pictures, I was there. I was there.
where do I find these pictures?
Maybe I have some. I don't know. But I remember now very well. You and maybe your sister, your cousin. Kelly was talking to you, trying
My
to
sister.
get you to be what you call regional developers or something like that.
Yeah. So the first time I met Kelly, I'll never ever forget it. He asked me for my call card. I don't know if I've told this story. He didn't say anything. He said your call card. So I gave it to him, and he did this. He took the card and he went like this. And he said, "You know what this card says about you? You're cheap." That was the first thing he said. You're cheap. Okay. So back then I had my language center, a whole like a little one floor above a shop lot, and I was running my center there, right? So yeah, it was the cheapest way I could make the call card and make it work. So then
Do you remember this? This arrow.
yeah, that's right. Yeah, we did the arrow.
Yeah. We did this. We put the arrow on your plexus solar like this, and you press until it breaks. You remember that? That's the arrow.
Oh.
Yeah.
So yes, and finally, I think about 4 years or 5 years later, Kelly, this was Kelly's own training. He was here under Success Resources. Then I went, I said, Kelly, I passed him my new call card, and then he did this again. And what boggled my mind was that he remembered. He said, yeah, this is fine. That was Kelly. Yeah, but anyway, Manu, thank you. Okay. I know how to find the photos, but let me go look for it, yeah? And see online or whatever.
Yes.
Yeah, if you can, yes, please. Yeah.
Okay. Okay, now, if you allow me, I can give my 2-cent opinion on the minimum of 2. You remember that it came down to the tetrahedron, huh?
Mm.
Remember the 2 poles. The 2 is very important. 2 poles. A radiative explosive pole and a gravitational pole. The plus and the negative that they hold. They are poles. They are fixed. They are pointing to where we want to go. When you collapse down to the tetrahedron, and it says something that maybe you didn't get. It says the tetrahedron inverted itself. The door of the tetrahedron. It says so. To do that, you go to what you call the 0 point. Right? If you remember the tetrahedron, if you hold it, it goes through a 0 point and then explodes. Does it say anything to you? So if you go into the, how did we call that, Steve? The 0 point, and it's like a tie, the bow tie. What is the volume of a system? at the 0 point of the bow tie.
You got me.
It's
What
zero.
is it?
It's zero. It's 0 minus and 0 plus at the bow tie. So what is the volume of a system at that exactly that bow tie? When the tetrahedron is inverting on itself, what is the volume? It's 2, isn't it?
Yeah.
We have the minimum of unity. That unity converts is a tetrahedron. The tetrahedron converts into a bow tie, maybe an ought to draw. If it converts into a bow tie like this, at the junction, at the moment when it's coming from 0 minus into 0 plus, that side, what is the volume of the system? It's 0. It's a 0 point. And if you get into that noodle sphere in the middle, 0, then the system is reduced to its poles. I'm holding down to the volume of 0 of a concentrate of universe. It is the black hole and the star together. Next is going to explode. Do you understand what I say?
You said
Okay,
it's
let
going to
me
explode.
Okay, I say the minimum system is the tetrahedron. It says so.
Yep.
The tetrahedron has a dual because there's always a hidden part. The real part is actually what we see is an image. Another point important that he says that the real thing, the sign, like sinus of a system, is always hidden. The cause of a system is always hidden. That part of a tetrahedron is what you call the divergent tetrahedron. So if the tetrahedron is a black hole holding all the energy, that energy has to be funneled out into another tetrahedron that explodes to expand, to become stars, to become octahedron and all these things. Have we got that? The tetrahedron the diamond never stays the diamond forever. It falls and then the two are always going together. It is phasic. One phase, it is a tetrahedron, 4 bonded. The other one is a divergent tetrahedron. It goes through a 0 point because energy is continuously flowing. You reach that unstable equilibrium where it changes phase. If it changes phases, it gets into what you call a divergent and explosive tetrahedron. Have you heard about that? An explosive tetrahedron is this one. This is the explosive tetrahedron. You see the one that is red here, this one here that I'm holding, I can call it a gravitational tetrahedron, this one. You see that? I'm holding 4 vertices here.
Mm.
These other 4 vertices that I hold now is the explosive tetrahedron. Is the dual of this tetrahedron. That's what Becky did, folding them. Then when you put them flat, you open them together, they are flat. Is the flat that Richard was talking about. So this area here, that is, you see this, the red trace, the green trace, and the blue trace, right? You see the red trace?
Yeah.
Here.
Mm.
You see the blue trace here, and then you see the green trace here. Do you see those? The volume that is inside is what? That is the core. That is the central sphere, isn't it? That's the center of this tetrahedron. That volume is 0. Is compressed until it's like if you get, let's just put it this way. If you take a ball that is that is an inflatable ball, right? In your hand, it's small enough. And then you press it like this. You press it, you press it, you press it. When you reach a certain level, what does it do? It explodes out. It come out. If it was a tomato, it will come out of this hole here, isn't it? But the two didn't happen at the same time. Remember that it is pulsative. It's one after the other. It is pulsative. It's because I was pressing like this that the tomato that is in my hand explodes. And when it explodes, it goes out through the gaps. Now, what is the volume of this system of a tomato in my hand? At the time, just before the explosion, what is it? What is that volume? It's concentrated to a point. Which Becky reduced to a sphere, a central sphere, what you call the core. And the volume of that core is zero, basically. All is concentrated there is zero. Is 0 plus and 0 minus. 0 minus, 0 plus. So this system, in the end, at that point, exactly at the minimum, that energy is minimum, is reduced to 2.
Okay.
And the 2 are the poles that I hold. Remember that I hold the pole, they don't go anywhere, they're in my hand. I'm pressing on them. Those are the poles. So universe is plural at the minimum of 2. Because that is the absolute minimum energy, minimum concentrate. Otherwise, we'll be in a theory of probabilities, in a theory of uncertainties. You don't know what it is. Universe has a purpose, in my opinion. I don't know if I explain it in a way that made any sense, but that's where the 2 is. And that's the same 2 that you find in Euler's identity. That is, say, if you take a physical universe, completely reduced to the expansion contraction, you find 2. Vertices plus faces. Vertices plus faces is what? Is the explosive part. Minus edges, minus the electric part. Magnetic minus electric is 2. The magnetism goes out through the windows, the faces. Magnetism also goes out through the vertices, out like that. Electrical flows between the vertices. That is energy that is looped, is flowed on the edges between vertices. That's the way electricity flows. Electricity doesn't flow on the skin. It flows on the lines of energy. So if you take the magnetism, which is vertices plus faces, and you take out the electric between the edges, what is linked, all you are left with is the 2 poles that you hold. And the triangle of those 3 things makes the system. Okay.
Okay.
Okay, my turn, right?
Yes, please. Yes, please.
Well, I started off with trying to understand the phrase that says unity is not oneness. And then it goes on to say it's unity is plural minimum 2. And there's 2 ways that I try and put that together for me is, again, going back to what Fuller talks about in terms of self, in order for self, there has to be awareness. In order for awareness, there has to be otherness. And then reverse that, no otherness, no awareness, no self. So that tells me that self, if you want, in order to be, has to have at least other, so minimum two. The other one that I've worked with, and that's where we've talked about this too in the H relationship, but in the marital union concept, that unity is not oneness. In other words, it's not one person folding into another person, or vice versa. It's two together, minimum two, and which I always find is interesting is that the common marital vow in a number of cultures is this idea of marriage in order to become one. And that to me is an assumption that unity is oneness, and that somebody will fold into, if you want, the life of the other. And so that's how I'm working with it, is minimum two in the order of self and other, in order to create something, and the minimum two for oneness in something like a union, a people union, whether it's marital or some other union. And then with what Manu was explaining, I think what I got out of that is that with the crossover with the bow tie, unity is not that 0 point. Unity is minimum two, the two sides, the two wings. Whereas a lot of people might think that the 0 point, that crossover, is unity. But you have to have both together in order for the unification of those two wings, if you want, those two butterfly wings. And so that comes out again to what he was talking about in terms of minimum two. So that's how I've tried to answer the same kind of question when I ask it of myself, in terms of what is unity? What does it mean when it says unity is not oneness, it's minimum two, it's plural, minimum two.
Thank you. I'll share what I'm getting later.
You'll what?
I'll share later what I'm getting from both the explanations already.
Okay.
Steve, you want to add something to this?
Well, I almost understood and agree with everything everybody said so far. But for me, this idea of there's a magic word that hasn't been emphasized, and that is that I totally agree that unity is a minimum of two. So there are two involved in unity, but the thing that I tend to want to forget is it's the minimum. In other words, the problems just begin there. They just
Right.
start there. I have big problem until I acknowledge that unity is a minimum of two, but that's the minimum, and so there's much more. And I think the minimum word is highly underrated, and I just wanted to bring that up.
Thank
Other
you.
than that, and I tend to think of it in terms of just consciousness. That none of the tetrahedron wouldn't be there if I weren't conscious of it in the first place. And so this consciousness, as Richard pointed out, and I think as Manu would point out, implies the essentialness of otherness in order to have a conscious experience. There has to be at least two. There has to be a minus, a plus, a minus. There has to be you and me. There has to be something and something else. And that's just the beginning. So that's where I am.
Okay. So this is what I'm getting. Thank you so much. Okay, finally I'm beginning to see that that wham kind of thing, because Manu, when you talked about, you gave me the signs of it, right? Just now the explanation. At first we as usual, okay, we listen, and the way your brain works, right? Sometimes we're not even sure if we're getting something, right? But we do. It's just that which moment it shows up that we suddenly, whoa, we get it. And that happened just now when you went down the path of the fact that it's absolute minimum energy, right? When you went down to that and talking about the North and the South Pole. So why every time the thing is, now I'm getting that every time any one of you start going down the path and just mention unity is plural at minimum 2, is that you are not looking for, but straight away you can see the minimum for literally the universe and us to work, right? So that one I got that. And then Richard, when you talked about this straight, okay, now I get it. This unity minimum of 2 is, you're linking it to now the human part, which is the self and otherness. Okay, and for that to exist, it's the awareness. So yes, we talked about that too, and now I'm being able to pull that together. And Steve, you're right. The keyword is minimum, right? The minimum. So you're looking at that minimum system, that minimum something to make the thing work. If you don't find it or you're not aware of it, because when you have that minimum and right at the core of it, I think it makes it easy. This is what I'm seeing. It makes it easier to extrapolate from there, or to because sometimes when you look at something this big, it's not easy to grasp because it's just too complicated, right? So when you get down to that, then from there you work outwards. Okay, so that was what I got, and thank you very much. So certainly it ties in why this pops up so much. Okay, sure.
Yeah.
Cool.
Well, let me add another thought that's in my mind around this, because the idea of oneness, and that two become one, if you want, to me, it seems to be awfully close to what is meant by colonization and what's meant by assimilation. It's the idea that we're going to bring these two cultures, if you want, together, or we're going to bring the winners and the losers together. And one has to fold into the other in order to have a new unity, let's say, rather than realizing that the oneness is really honoring, if you want, the separateness of each other, and that we find a new way to bond, and which for me then speaks to Boehm's dialogue, that if we brought the two cultures together, then we dialogue to have a consensus emerge of what do we want from both of our cultures to be something that we share with each other. We would get a different idea of unity in a sovereign sense or in a cultural sense, and we would be hard pressed to not have multiculturalism, because we'd be saying that it's minimum 2, but it can be way more than 2. And that there would be this dialogical sort of seeking of a consensus or an emergence of what's going to work best for all of us. And we're not going to force somebody into somebody else's culture, even on the idea of, winner takes all in a, at a game level, or even at a cultural war kind of level, that if I defeat you, then you have to fold into me. And that will be my new definition of oneness. You become me now. Which doesn't seem to have worked very well over the centuries.
But Richard, what you said just now about assimilation, I think I really like that, because when you went down that path straight away, I'm thinking dynamic equilibrium, yeah. So that's what I mean by suddenly, okay, I can see that. So the one I could not was this unity is plural at the minimum too, and now I do. So thank you. And then as you discuss, oh yes, that's dynamic equilibrium. And I'm actually thinking of, I do videos on all sorts of topics, right? On education side. And I'm so, I'm like thinking I really should do one on this whole thing that the generation today, the younger generation working today, seem to have this fixation on, and it's not working out for them. It's not working out for all of us, in organizations working together and so on. And it's this whole idea of work-life balance. Okay, so we should be looking at dynamic equilibrium, and I had a very interesting discussion with my daughter just 2 days ago when my husband we were taking care on Grammy and grandpa duty 2 days ago. And because my daughter is part of the business, and we were discussing, she's concerned about our people, like they have so much work to do, and then we're asking them to do this one thing extra. I'm like, no, it's like you're going to have to, we cannot be thinking from the space of a work-life balance, because it doesn't exist. It doesn't exist, because people are thinking of work-life balance as in, if I spend to them, I must have equal hour at home and equal hour at work. That seems to be how they're thinking. I realize that, because sharp, work done, and off they go. And then the minute they find that there's so many things to juggle at home, kid and parents and so on, and some of them have come back to school, to our workplace, and say that, look, I'm dealing with all this, and therefore I cannot manage this. So we end up having to manage their work-life balance, and we have to solve the problem for them, And I don't know if you heard of interviews where the young people, they go to the interview, and so they ask for a very high amount for, let's say, a pay that's quite high for whatever they're doing, or their initial job, right? And the reason, why do you ask for this amount? Oh, I need to take care of my family and my parents, that kind of thing is their answer. I'm like, wow. So the thing is that you get your value from an organization when you solve problems for people, right? And you help bring in the revenue to sustain the whole thing, so it solves problems for everyone. But they are looking from the space of solving the problem for themselves only, and some of the amounts they're asking for is ridiculous. So you get what I'm saying? So it's that work-life, that outside of that is more the time. When they don't it's life comes at you, right? So the older you get, the minute you have a partner, you're now thinking of two, and that means the two has got people around us, right? And therefore you're not handling two persons, you're handling his parents, your parents, his family, your family. Everything doubles up, his friends, your friends, and his problem, your problem. Parents get sick, both sides. In-laws, children need help with the kids. Your issues double, triple, quadruple, and so on. But they still want that work-life balance. As in, and I had this discussion also with my daughter's boyfriend, the early boyfriend. He had no idea what he was asking for, when he insisted on, that my daughter must, why are you working so hard, and so on. Anyway, so that's coming back to this. But
And so, Anne, are you complete?
yeah.
Okay, so and as I'm thinking about this, I keep coming back to this minimum of two. And so that's a good place to start, is the minimum of two. And like you said, hey, I've got me and my family, him and his family, and so it just starts to double. But it doesn't actually double. The relationship is four-dimensional, and it becomes a hypergraph. And the formula is n times n minus 1 divided by 2. That's the formula. And then to go to the next level, I have to understand that I have a relationship with myself, and you are entitled to have a relationship with yourself, and I get to no longer divide it by 2. I get to multiply that by 2. So I move into a four-dimensional hypergraph of interrelationships by the formula n times n minus 1 over 2. So to me, that's the crowning thought of simplexity.
Thank you for that. Yes. So I'm like, do I not do the video? Because I know this kind of videos you get vilified by those who are so strong in and the ones that will think that no, they're talking about work-life balance, right? But we're talking about the fact that they all have to come together, right?
Right.
So anyway, that's I don't know. I'm still like debating. Do I start with something like this, or do I start this because it's driving us nuts? It's driving us nuts.
I think Richard's point that unity looks like assimilation or some kind of imperialism. I think that's the first tendency. That's the first thing to look at. Is unity an assimilation? Is unity some kind of empirical, the empire? Is it somebody has to win and somebody has to lose? No. And that's the first challenge, I think, is what Richard points out right there, because that's most people believe in some kind of collapse or compromise. And it's not about collapse and compromise. It's about expansion and the minimum. Richard, did that inspire you at all?
Yeah, well, you're on the formula thing. You were thinking the same thing that I was thinking, and it was reference to the people that Anne was talking about and saying, I need money to pay for all these things. But what I always go back to the experience that I had of getting people to count how many things they're having to juggle or deal with in their lives, and then apply the formula. And especially if they're saying, I'm having trouble with particular segments, either the in-law segment or the family segment, and when the formula is applied to all the things that they can name, then it will come out as if, oh my gosh, look at all the relationships that I'm handling well, and there's only these 2 or 3 that are driving me nuts. And oftentimes those that are driving us nuts turn into I'm failing, or I'm not good enough, or I'm not being appreciated by others enough, like I'm not being paid enough. And when you put the 2 together, then you have them able to sort of say, "Oh, I'm pretty good, actually. I'm amazed at how much I'm handling every day of all these relationships." And some of them are not even conscious. You're just doing them because they come naturally, type of thing. And that was what was so exciting for me with this one example where I got a person to count up all these vertexes, and we did the formula. And her spontaneous reaction when I gave her the big number, she said, "Oh, well, no wonder I wake up in the morning with a headache."
Yeah.
It's like all of a sudden she claimed a right to that headache.
Right on. Perfect. Go ahead, Manu. I think we're ready for you. Go ahead.
Sorry, I was playing with something. What is this?
Part of a Q octahedron.
Yeah, but what is it in life, in our
It's
life?
a house.
It looks like the frame of what might
The
be a
tipi.
house with
It's
a.
your tipi, it's my rendezvous, it's everything. That's what, when I see a house in 2 dimensions, that's what I see.
Yeah.
Okay? Now, this guy, the roof doesn't move, eh? And this guy is just dancing, eh? But because this is a system, Look at this green. It bound to this guy, right? It's always, let's just put it, these are my pose or whatever, you know. But it's always dancing. So the triangle and the square is the beginning and to teach kids. You give them batons with, you know, they build this stuff. And you show that this one, like a house, doesn't move, but that guy moves. But this guy is moving like this. Look at what he does. Look at what the natural thing. This guy is doing this, huh? Going to this. This guy is not going to be falling to this. This guy is difficult for him to get into this one. Look at what the green guy does. Right? Because he can do that. The green guy does this. And what else is left? This pumping continue now. This still a pulsating system, pulsative. And then this guy turn like this, right? When he's here, look at that, the angles, the radius from the center of this system are decreasing. And this guy is increasing on this dimension. Look at this. That's the basic pumping. Huh? All I'm doing is moving this thing like this. This guy, this is fixed. And I'm moving this two like this. This guy is, I'm pressing here. That is moving it. This guy is increasing here now. You see that? Now, when he increases like that, if this guy comes here, look at this. What is left? Where's my thing? This other guy comes here. Let me use the red for the sake. This guy comes here and lock there. What do you have?
An
Half an
octant.
octahedron.
It's an
Yes.
octant.
Yes, we have a pyramid. Just for a simple game, eh? You started with a flat. The guys, your kids are on the floor. They do this on the floor. It's moving like that. This doesn't move. Take this. You can even put two like this. It already closed into a triangle down here. And then you take this one up like that. But less natural. It is. But notice that the pyramid is still moving.
Yep.
But the total that the pyramid will be stabilized when this part here is linked to another thing. Is linked that other way through the face. That is, you're fixing the face. You are bracing the face. It will be stabilized. So, and it will be stabilized with this invisible part. This that I hold in my hand is stabilizing that thing in the ground. You don't see it. This is quite a nice way to introduce that the cause of this stabilization is in pure sign. You don't see it. You see the orthogonal projection onto this plane out here. That is conversion in the form of a house. When we are building the foundation, because the earth is like round like this, it's curved like this, we are building the square of the foundation, and subtly inside, it is locking into this double octahedron, double pyramid. It looks like this. When we build our foundation, that's what we do. We implant our foundation in the ground, but it goes, those things converge like this. Now this guy is stable. This is our house, the same house. Then we leave on top of, into this one. We leave here. This guy here, the green part, we never see it. But remember that the green part is the cause of this guy here on top being stable. The cause wasn't this red and green part here. It was never the cause.
Would
The cause
would
of
that be
this.
sorry? Would
I'm-
would that
I'm
be the
try-
would that
Yes.
be the invisible? Sorry, just is that the invisible negative counterpart?
Yes, yes. Then negative mean gravity. Remember that
Okay.
negative mean gravity. So the reality that we see today is not the real reality. It's a mirror image. When I see Anne, is a mirror image.
Yeah.
The real Anne is deep, invisible. You see what I'm saying? That this is just to embed into kids the notion of that invisible part. This is solid because this one anchor into this thing here that is on the ground. You don't see. Because we every day we explain the image to us, and we live believing that the image that we have is the real thing. It's not. The cause. That's why I always say we always live in the past. What we realize was caused by something that we never see. We never see the cause. We never see the cause. We never see the action. We see the reaction and the resultant. We never see the action, the real sign thing. We never see it. Okay, I'm through, Steve. Sorry.
Oh,
Thank you so much for taking the time to explore this. Yes, now I'm looking forward to that minimum of 2 with the jitterbug. Yeah, good to go.
cool. And I think reading ahead,
It's for Anne to, sorry, it's for Anne. Please experiment that with kids and let us know what you get. Because that's the way we grow to experiment it. Do it with kids and let us know what you get. If you have the impression that they are getting those notions.
Okay.
That would be very helpful to us. Okay.
And I think before we close out, I think we can finish the last 3 paragraphs of our reading, because I think it's going to add to the conversation we've had so far and be a perfect ending of this section, and therefore a perfect ending for tonight. So I started reading. Does anybody want to read this last section here on volume and phase changes?
Can I read?
Yes, please.
Okay. Volume and phase changes. The jitterbug exhibits a total transformation of shape and size without any change in material. Nothing is added or taken away, but the system's characteristics are profoundly altered by rearrangement of the parts. The concept is reminiscent of the differences between ice, water, and water vapor, all consisting exclusively of water molecules. When a child whose model-making experience is limited to building blocks first learn that rearrangement of the constituents is responsible for these profound changes, the idea is not easily accepted. Fuller maintains that experience with models like a jitterbug will better prepare a child for a lesson of science. Chemistry's invisible phase changes would seem perfectly logical, as they would be consistent with first-hand experience. And indeed, the jitterbug's floppy, flexible behavior as vector equilibrium is parallel to that of a gas. The dense tetrahedral configuration with its motion totally restrained is more like the solid phase. Same stuff, radically different properties. Steve?
What's that? Oh, I'm sorry. I've been reading out of the book. Here we go. Hang on. Thank you.
Where were we now?
We're right here.
Okay, same stuff, radically different properties. It has a point. These dynamic models inspire a different kind of conceptualizing. At the 0 point, 24 wooden dowels and 12 rubber connectors embrace a volume of 20, as we recall from multiplication by division. After contracting and twisting to the jitterbug, the bundle of stick encloses a single unit volume, 1 tetrahedron. The system has thus gone from 20 tetrahedron volume to 1, with a stop at 4 in the octahedron.
Cool. Comments on that? I think that goes a lot with what we've been talking about in terms of demonstrating with kids. And I think that it comes back to this idea that I got the last little while, that fluid dynamics, if we started teaching science from fluid dynamics, we'd be a lot more, instead, if we started learning about how water acts, we'd learn a lot more about our universe. But we don't learn about water, we learn about sticks and houses and balls instead of like water. Any other thoughts or comments? Cool. Well, we have a little bit more time, so we can continue. Go ahead, Richard.
Yeah, I was just going to say the other thing that I learned from Fuller on this is the reference to the importance of chemistry and chemistry modeling.
Yes.
And that how this kind of learning has been vacated, if you want, and replaced with sort of the mathematical modeling, I guess. But he's really saying that we lost something when we gave way to something other than chemical modeling. And it takes you back to this Van Hooft, who got the first Nobel Prize in chemistry. He got it because of his way of modeling and putting together the tetrahedron, the geometry of a tetrahedron. Yeah, so it's and I like that one phrase that has to do with the dynamic models inspire a different kind of conceptualization, or conceptualizing. And that to me is so important in terms of learning from the point of view of how do you put things together and create a new concept, a new model, a new way of visualizing the map, even though you also acknowledge the map is not the territory, but it's often a very good guide or facilitator.
Yeah. It comes back to the point that we teach from static models instead of from dynamic models.
Mm-hmm.
Yep.
I'm becoming convinced that the first principle for everything is what Kelly used to say. Energy flows, energy always flows, energy flows to the line of least resistance. I'm becoming really convinced that is the first principle of everything.
Mm-hmm.
Steve, can you repeat that? We teach from static what again? Instead
It
of
says here on
dynamic.
page 183. It says here on page 183. Let me get it for you because it's right there in the book. And I just was, although I did ad-lib a little bit, I just was repeating what Manu had read. Here we go. And it reads as follows. These dynamic models inspire a different kind of conceptualization. This is what Richard and Manu, this is what we're all talking about here. And indeed, the jitterbug's floppy, flexible behavior, his vector equilibrium is parallel to that of gas. This comes back to the chemical. The dense tetrahedral configuration with its motion totally restrained is more like a solid phase. Same stuff, radically different properties. He has a point. The dynamic models inspire a different kind of conceptualization. So we have static models and we have dynamic models, and we've plus the fact that complicated, as Richard, I think, pointed out with mathematics, or was it Manu? We take this theoretical thing, math, and we strain everything through that math. And the math is not dynamic. But if we take models of real life, there we are. Okay.
Just a bit of an update, yeah. You know, when we work in education, the lag is so long. The lag, you know. So like the last time the sun sight and sun eclipse, right? And sunrise, sunset. I took it to my teachers, the science teachers, and I told them, you test it out for me, right? So I think they did attempt it once, and I realized, oh my God, I got to set up the whole like the whole structure of how to run it, because I don't think we got anywhere with it. So just in case you're wondering if I took I took it on and tried it out in the school, which I did, right? But I realized that it's got to be structured the way to get the real awareness out of the students, and for them to have that whoa moment, right? Now, and the thing is that it's got to start with my teachers, right? So a lot of people, when it comes to education, the lag is an 11-year lag. I had one parent who was very impatient with me, because he was talking about this exponential entrepreneurship, and then he came to me and talked to me about the things that we needed to add in, you're talking about solving problems, right? And 10x and 10x the value of a company, and be able to solve problems bigger, better, faster, cheaper, safer, greener at the same time, all that, right? And then so the point is that you literally have to. Oh no, sorry. The one that he came to me was on the AI side. The AI, there was the digital side, and he didn't realize that in order for me to implement something like this, I've got to make sure there's a program to be developed from year 1 all the way to year 11. And the first people you have to educate would be the teachers, and the time it takes for the teachers to develop it across 11 years. Yeah. And that's the kind of lag that we face in the school. College will be faster because you're dealing with the older ones, and you can have it within the next 3 years. But then even then there's a lag. It's not immediate in most cases. So the point I'm getting there is, as it stands, whatever we're doing in our school, we're finding it when we want to replicate it in different countries, the point where there is the resistance, the thing that makes it lag is actually the teachers teaching it, because the capacity to talk like the multi-layered, multi-dimensional, multi-layered, this hypergraph thingy is not what they grew up with. And we realize in Indonesia, in Thailand, we have huge problems trying to get them to come from this space to even begin, even though we've got curriculums written out, and they just need to follow it. The first thing, you know what they do? They just don't do. No matter how much training we give them, they just don't do. And then before we know it, they go off someplace else. Even in my school, we face that sometimes, because we're teaching math from, we're starting the kids with concepts that integrate, like they lead from one to the other to the highest level at a young age, right? So nobody's teaching it there. And so they leave our school to go to another school where they do less. And so it's easier. The job is easier. So that right there is the resistance. Lucky for me in KL, the teachers in Klang Valley, the ones that are staying on with us, they're driven by this. But then you have this other half of issue where they will leave because it's just too difficult. What I'm teaching science, but you know what I have to teach? I have to teach this what do you call this creativity. I have to get them to integrate with one another. We've got to teach them the human interpersonal skill side, in science, and they don't even they themselves may not even be very good with the interpersonal side. So that is a major challenge, right? And so we created the curriculum that shortcuts the thing, but then you have this other thing where they can just choose not to, and we don't know about it until we find out when it happens, or when we do that checking and things like this. Yeah. So I'm just I'm complete. It's just something that I'm sharing. So lag time, here we come. But I'm gonna talk to my people. Okay.
Yeah.
Yep.
Let me,
Go ahead, Richard. And I had a
Yeah.
big epiphany listening to you talk, Ann, too. So go ahead, Richard.
well, what came to my mind is the field trip idea, and to take your teachers on a little field trip outside the school or somewhere, and or the kids, and to, in the evening, as the sun is setting, to stand there and look at the sun, if you want, disappearing, and then just, it's almost like a meditation of close your eyes and experience you traveling 1,100 miles an hour on the surface of the earth, and all of a sudden the earth will come in between you and the sun. And then get them up early in the morning, some morning, and go out and face east and do the same thing of watching, feeling, traveling 1,100 miles an hour, and all of a sudden the sun's going to appear, and so you get that experience, that feeling experience of the Earth spinning, if you want, rotating, and you're traveling, and that's how fast you're going, and that's why the sun all of a sudden appears, like it was just spontaneous.
I like that. Or you're traveling with the sun, so it never sets because you're following. When the sun rises, you're following the same direction. Yeah.
This would be a perfect virtual reality game. I mean, think about this, Richard. You got a virtual reality thing there. You imagine yourself on a magic carpet, and you have a little speedometer on your carpet. And if you go a certain speed, the sun falls behind the earth. But if you go a certain speed, the sun never falls behind the earth. And if you go a certain speed, you actually pass the sun up and you come around on the other side. Think of that as a virtual reality. There's a project for your students, Anne, to create a virtual reality game just like that.
To
That is
show
so
this.
powerful. And then what if we took other aspects of our very existence, put it in a virtual reality, and allowed people to have the experience of reality without domestication, without cultural domestication, without cultural indoctrination? Wow, what a
Yeah.
powerful thing that could be.
Yeah,
I have another thing too, but let's don't move off of this too fast. Go ahead, Richard, if you have a follow-up on it.
No, I was just saying the other field trip is, again, to stand outside somewhere and then look up into the sky, only get the feeling of I'm looking out, from the surface of the earth, out to outer space. I mean, there's the correct language even. Or if I'm looking down, I'm actually looking in to the center, to the core. Um, and if we were working with the geometry and the notion of radii, then we would be able to see that I'm looking in the vector, if you want, to the center, and you could figure out how many miles that might be, or but it's again that field trip to sort of experience out and in instead of up and down. Yeah.
Yeah, actually, you got something there. Let me test it out. Let me talk to because we have this, we're working with these Koreans, where they have this augmented reality, not component, but a setup, which we have done in our school. It's the first, what they call ARO thinking, ARO thinking program that we have in our school. And so it's like we have this box, which is not small. It's about 10 feet around and above. So they have this game. They have this. Okay. It's augmented reality. So you just project whatever topics it is that you want taught that day, right? So, and for the kids to explore, and it's not about teaching them. It's about them. If it's by the beach, then all the three sides. Okay, one even up the ceiling and the sides and the floor is the beach, right? So, and the kids are learning about collecting, the marine creatures or life, and they'll be running around getting the shells and whatever else shows up, at the beach, right? But there's one particular topic which is the ISS, yeah, the space station, and you are standing there, but then you also are approaching the space station, and then you can literally be standing on the space station and go in and explore the space station. So you touch and you move and so on. So maybe I should ask my students to create a program. How do you travel in a way where the sun never sets? How do you travel? And toss it out there for them. Yeah. Okay. So let me have a thought and see who we can rope in to try something like that. Yeah. I love it. Thank you so much, guys.
Well, I have one more thought on this, but I don't want to detract from anybody. Mona, you've been quiet for quite a while. You want to say anything? I have an important thought, but I don't want to be a pig. Please,
No,
Mona,
you
say
say
something.
first because mine is a little bit out
Okay.
of,
All right. So
is the next
you do
paragraph.
yours.
Just
You'll
do
do yours and your takeaway. Maybe this will be my takeaway. Okay.
it. Okay.
Because I have wanted to put in my book, Extreme Mindfulness, one of my major points that I want people to take away is that every person reading the book is nothing more than energy. I want them to see themselves as energy. I don't want them to see themselves. They have a body, sure. They have attributes, sure, but they are energy. And how is life different when they're energy? And I really love this conversation because, as Manu continues to point out, and as Kelly has pointed out, and as Bucky points out, energy always flows. Well, that's the trouble with our static models of reality, is they're not flowing. They're just static. They're sitting there. So I can study architecture, but it's not flowing unless I make it flow, right? Unless I put something in it to put in a defect or put something in it to stop it from flowing, right? Because a house wants to fall over unless I put in that crossbar. So this idea, how do I convince everybody that they are energy? Well, it dawns on me that it depends on the type of intelligence that people are using when they're reading the book. I mean, and there are many types of intelligence, but some people are intellectually analytical, some people are analytical, different things. But one of the things that hit me was about how important water is. I noticed that Amy here in her book mentions water, but she only mentions three of the stages of water. She doesn't talk about the fourth phase of water, which is now a big deal. I don't know if you've I've got the book over here. It's called The Fourth Phase of Water. Now, I can't remember who it's by right now, and it's back over there, but there's an electromagnetic state of water where water actually is a battery. And when you move certain things around, there a bunch of plus ions gather together, and water is more than just ice, water, and rain or vapor. There's that fourth stage. So this may sound weird, but one of the things that hit me was the book Siddhartha. You guys know the book Siddhartha?
Mm-mm.
Siddhartha is written by Hermann Hesse. He was a Nobel Prize winning literary dude, and he wrote a book called Siddhartha. I will drop a link in the little thing. But what happens is Siddhartha, Buddhists hate that book because the Buddha's name was Siddhartha Gautama Buddha, and the book is by Siddhartha, is named Siddhartha. So Buddhists hate this book because it's too much like the Buddha. But I think Hermann Hesse's very ideal was it was very much about the Buddha from a non-Buddhist point of view. So there's a big whole life journey, but right at the end of the book, something miraculous happens. Govinda is a lifelong friend of Siddhartha. Govinda had all these life experiences with Siddhartha when they were youth, but somewhere around the 30s, Govinda, his friend, heard about the Buddha and wanted to follow Buddha and become a Buddhist disciple. So he went to follow Buddha, and Siddhartha was left on his own to have his own experiences. And Siddhartha goes through all these amazing experiences and finally ends up as a very successful businessman, seeing no purpose in life at all, throws himself into a river in order to commit suicide. And the river coughs him up on the bank and he survives. And so Siddhartha becomes the ferryman on the river. And so he's taking people on the river, which of course is a metaphor of life, isn't that right? Going from one bank to the other and crossing over this flow of life, right? And making a decision to get here and there. And finally, the Buddha is 80 years old, and the Buddha has announced he's going to die on a full moon on his 80th birthday, upcoming birthday. And so Buddhist priests are gathering. They're from hundreds of miles. They're coming over to the city where Buddha is going to die. Lo and behold, Siddhartha is a ferryman on this boat, and these bunch of priests are coming across the river to go see the Buddha. And one of the priests is Govinda, Siddhartha's friend. And Govinda does not recognize Siddhartha. Siddhartha is an old man, gone through so many things. And at the end of the trip, Siddhartha says, Govinda, it's been fun talking to you, but you don't recognize me. And all of a sudden, Govinda goes, oh my gosh, it's you, Siddhartha. Whoa. And they have this flood of exchange for a few minutes as Govinda's got to get off the boat and join his people going to go see the Buddha. And Govinda bends over to kiss Siddhartha on the forehead in honor of their friendship. And as Govinda bends over and kisses Siddhartha on the forehead, he sees the river. And all of a sudden, he sees the river in 4D. He sees the river as flowing to the ocean, as evaporating up into the clouds, flowing over to the mountains, and then rain falling in the mountains and going into the creeks that go into the thing. And suddenly he sees water not as water, but water as a process, as a dynamic process. And Govinda has this moment of enlightenment where he sees the world the way that it really is, as a dynamic, flowing system. I don't know, to me, and that I almost have tears in my eyes because I've been asked to actually present that book in some high schools with some friends of mine, and it's been such a powerful thing. And this conversation tonight about dynamic models and static models has just been really critical. So I don't know if Siddhartha might convince somebody, if they could imagine themselves kissing Siddhartha's forehead and getting that vision of water as a process instead of as a dynamic model of molecules. Anyway, that was big time for me. So, and that's going to be my takeaway. I'll end the call, however, tonight. But I'm grateful for all of our discussion, and I'm so grateful for you just venturing out and say, okay, hey, what does this mean to you? What a beautiful opportunity to think and ponder what it does mean to me, and to hear Manu and hear Richard and hear you put it all together. It's been really wonderful for me. Okay, Manu, what's going on for you? How are you feeling? What are your takeaways? And pass it along to Richard or to Anne
Okay.
or wherever you want to go.
I feel good and I feel grateful and humble. What I take away is 2 points here. There are many others. The 0 point is not zero. Zero is not null. Zero is the minimum volume. That's what we see. Zero is the minimum volume. It is a phase that is unstable. It's a cube octahedron. In the book here, she say the cube octahedron is perfectly zero here. She wrote it on page 184 of the book, at the top of it. The cube octahedron is definitive, absolute zero. That's what she said. The second thing is here. Look at this experiment here. Look at, you see here, you have a rhombus here, right? Hello? See this rhombus?
Yes.
What I call extension of a rhombus is pulling like this, what I'm seeing. This is expansion, huh? But what does the other dimension do? When I
Collapse.
pull like that, it collapses. In order for me to see this correctly, let me rotate it like this. There's only one point, you know, like I'm pulling out and then I'm turning. Unfortunately, this is rigid. But my point is that at one point, this expansion is going to be in such a way that this shorter radius here between two vertices is equilateral everywhere, is the same everywhere. That is the icosahedron. You see what I did? I'm using, this guy is moving. I'm expanding it. This is expansion. When I push into it, it goes like that. It goes like that. And it goes to a minimum here. There's a minimum. That's the radius here. You see that this is like stable here. You see that? Look at this. I cannot go further than this. There's a minimum diameter here when I expand. You see that?
Yeah.
I'm holding it here. It's a minimum. Now, if I twist it like this, if I turn, I'm twisting like that, there's a point. Remember this radius here it was compressing. There's a point where these 3 points at the shorter distance of it are going to form an equilateral, triangles here that continue. My point is that this is a phenomenon that explains the lesser volume than 20 of the icosahedron as stable that is on the way to something. It is this expansion and this rotation that happen to twist and to shorten the distance between vertices into something that is of a volume lesser than the 20 faces that you have when everything closes. The radius is less than 1. So the volume is 18.5, I think, something like that. So that's another of my takeaways. And the third is, it is so powerful, the association of a triangle and a square, simple, into teaching kids of so many things in life. Otherwise, I'm grateful again, and I wish you all a fantastic week ahead. Richard, how do you feel? What do you take away?
Well, I feel good about the dialogue we've had and the emergence out of each of our reflections, and how this is for me came into this whole idea of emerged into this idea of field trips, and how important it seems to be now in education to have people get out on the land, experience the land, see things in their natural state. And it just came back to me that this would be a interesting field trip. But I must caution you, Zoanne, because I did an experiment with an 8-year-old boy, the son of a family, a close friend, at a Christmas party, where all the adults were drinking and yakking and talking, and the little boy was bored. So I took him into his mother's office, and she had a globe on her desk. So I taught him about the outs and in and sunset and sunset. So, so, so we went back out and we stopped all of the drinking and everything. And he said, "I have an exercise for you." And so he first of all said, hot air balloons. He said, okay, when the hot air balloon leaves the ground and goes somewhere, what direction is it going? and he'd already played the sunset trick with them, so they knew he had something up his sleeve. And he finally was able to help with the audience experience the idea that the balloon goes out, the balloon goes out and the balloon comes in. And then he went on to the sunset kind of exercise, but now he was annoying the adults. And they
Yeah.
got rid of him. And then his family went to Maui, to Hawaii, and when they were sitting on the balcony watching the sunset, he had come in and he'd play this sunset sort of trick on them, and they would all chase him off the balcony and say, "Get out of here! You're ruining the romance of of the evening." So sometimes kids will take the idea and run with it beyond what adults are willing to tolerate. So that's my big takeaway. And
Noted.
how are you feeling? What's your takeaway?
Okay, thank you, Richard. So that point noted, when children are concerned, yeah, got to give them a little bit more parameter as to, we have to tell them, don't use this in your exams.
Yeah.
A lot of the things we teach them, please don't use this in the exams. You give them what they want, is in the textbook. Yeah. Okay. So yeah, I think you've heard me share a lot of my takeaways are in the sharing. I just want to point out that we're missing Lee and Joe. I know that they would have gotten a lot out of our discussions today if they were here. Okay. So yeah, thank you everybody. And yes, happy weekend to all of you.
Okay. I just put the link to, well, I'm trying to put the link to the Siddhartha book in the cupboard. So
How do you spell? Just write Siddhartha first. How do you
it's
spell
what?
it? Siddhartha.
Okay. It's SIDDHARTHA. There's a link to the book, and I'll go ahead and spell it right here.
So SIDG.
SIDD, two D's.
Yes.
Here it is right there.
Yeah.
Siddhartha. Siddhartha, Buddha's name was Siddhartha Gautama, the Buddha, Siddhartha Gautama. Anyway, and just to say what Richard said, I used to do awareness workshops where I'd have people in and we just talk about reality. And I learned early on, do not have kids in without their adult parents, because the kids will get it just like that. And when they go home, they get tortured because the adults will not put up with it. And
Yeah.
so I learned early on, do not teach a kid without a parent when you're talking about consciousness, because somehow they got to take it home, or they've got to be in an environment where they can survive the ridicule, because they will be,
Yeah.
the truth is not popular.
No, I just quickly on that. I taught this sunset sunrise thing to one of my students who was a mom of two kids. She went home and taught her kids. And one boy, I think it was a boy, went to school. And when you have show and tell at school,
Yeah.
well, this was his show and tell.
Yeah.
And the teacher punished him for lying.
Yeah.
And made him stay after school and write, 400 or 500 lines as "I will not lie to my teacher anymore" kind of message.
Yeah.
And the mother, of course, went on the
Ballistic.
war path.
Yeah.
And so she came back to me and she says, "You have no idea how much trouble you have caused my family."
Yeah.
Yeah.
Yeah. The truth is hiding.
Yeah.
Yeah. And the other thing, Steve, what you said, I really can't wait for your book to come out. Please let us know. The one about we are energy for people to get that, take away with that one. I want to look
Yeah.
into the fourth phase of water too. Thank you.
Cool.
Yeah.
Good.
Love it.
But
Love
there
it.
is a very good book, Anne, that
Mhm.
we bought that. We have that book. You will have it digitally, Steve?
Yeah, I do.
But
It's
we
back
bought
here
the
on the
book.
shelf.
We studied the book some time ago and it was Susan leading that study. Maybe it would be good for you to, maybe, I don't know, Steve, I'm giving you homework to find where it is and then have a link to Anne.
Yeah, I'll
So
put a
that you
link
can
in right
take a look.
now. Here's a link right here to the fourth phase of water book. So you can get to it there. It didn't want to go in. Oh my gosh.
And then the link. Could you find also the link to the recordings?
On our Siddhartha?
Yes.
Oh,
On
I
no,
mean,
on
on the
the
fourth phase?
on the fourth phase of water.
I don't
Because we
know.
studied.
I will
We
look for it.
spent like 6 months on that book. We
Yeah,
spent
we
a lot
spent
of
quite a
time.
while. Here it is here, The Fourth Phase of Water by Gerald Pollack.
He's got a TED talk on this, yeah? I'll go and check it out.
Good. Okay. What a massive set of takeaways tonight. Thank you all.
Good. Thank
See you
you.
next
Thank
time.
you. All right.
Hey,
Oh,
and Manu, go ahead,
next-
Ann.
Next week I
No,
won't
no,
be
no.
able.
Just say bye-bye. Yeah,
Well,
that's what I-
hang on a second, Manu. And then you won't be
Sorry.
here next week?
Yeah, next week I'm on. We're having a family lunch. Sunday
Cool.
roast. Just putting it out
Cool.
there.
All right.
Right.
But you're
This
there on
next
Wednesday.
week.
Are you there on Wednesday?
This Wednesday I can make it. Yes.
And
Yeah,
Manu,
we'll
have
miss you. Yeah.
did you hear the email that Fred wants to get back on the calls?
Yes, but I didn't have something. I had a question about that.
Okay.
Does he want to get back in the call, or is it Susan?
No,
That
he
is-
actually contacted Raffers and said he would like to get back on the calls.
Okay, because when he left, he said he's fed up with this group. That's what he
I
said in the
know.
letter, I
I
remember.
was there when he said he'd leave, but evidently he's interested in coming back.
Okay, no, it's fine. I have no problem with that.
Good.
He was a very valuable guy.
I'll send him an invitation.
Okay.
All right, everybody. See you soon.
Okay.
Bye-bye.
Bye.
Bye-bye.
Bye.
Oh my gosh, I should have ended it a while ago.
Steve,
Yes.
please.